Welcome everyone. Today we are going to be finding area of circles. So again, remember my requirements. I want you to be listening to me, and writing down what I am saying and doing. Pictures really help if you draw the pictures out if you're not using a PDF, and pause when I say pause. So for example, right now, since this is a warm-up, I want you to pause and try to do this on your own and then check back. All right, let's see how you did. So first, I want to point out that some of you are not showing the formula every time. I said in the last video, I want you to write the formula so that way the more you write it, the more you remember it. So here, the radius was given. So I chose to use the formula circumference equals radius times pi, 2 times pi times radius. However, you could have figured out if the radius was 37.68. You could have multiplied it by 2 to get the diameter and then used C equals, so circumference equals pi times the diameter. Okay, so either one would work as long as you make sure you're multiplying the radius by 2 somewhere. All right, so I did that. I wrote my formula so you knew what I was using. I filled in what I knew, and since the pi was indicated I should use 3.14, I did so. I did the multiplication using a calculator, and here's my answer. We're switching gears because of area, so I want to get you back to something you're familiar with, and that is the area of a rectangle. So it says determine the area and name 2 different ways that it can be used, or that can be used to find the area. So the first way I used was the formula, area equals length times width. So I did 4 times 6 to get 24 units squared, or 24 square units. The other way you could find it is to actually just count up the squares, okay? And lastly, the question is find the length if the area is 27 centimeters squared. So I chose to use the formula, A equals length times width. And then I filled in what I knew. I knew that the area was 27, and the width was 3. And I just solved the simple equation. You guys have been solving equations for the last few weeks. So divide by 3, so length is 9. So the length would be 9 centimeters. So if we want to find the area of a circle, we could certainly split it into little boxes and count up all the little boxes, but because it's not a rectangle and not right corners, counting boxes would be pretty difficult. So I want you to think about a way that we could write a formula. So let's first look at what I did was I cut this into little different pie shapes, and then I cut actually them out virtually, of course, although we could do it by hand. And then I took these, opened it up, and I made a rectangle. With one of the pie shapes, I had to cut it in 2 and put it on each end. So I have this and I have this. Okay, so let's think about what each of these pieces mean. So what would this part be here? Okay, so what is this part? And what is this part? Okay, and then what about this? So what about one of these pieces right here? So take a minute and think about what part of the circle would be represented in this rectangle once we cut it apart. Okay, what I'm hoping that you see is all of these white pieces indicate this part right here, and all of these, the bottom of these pieces, indicate this right here. So this part right here is like the semicircle. And in the last assignment, you had to write this part in a formula. You were supposed to. So we know that the whole circumference is C equals 2 pi r. But if we only have half of it, we need to divide by 2. So the white part is pi r, and this part up here is pi r. And then we can look at these right here. So if you had one of these, what is that called? That is the part of the circle that is the radius. So now, think about, now that you can see this spread out, how can we, now that we have our rectangle, write the formula for the area of a circle? I'm going to just write it like that. The area of a circle, we have our length times our width, and we want to write it with as few symbols as possible. So I see that there's an r times an r, so the area of, and I drew a circle here, but I'm going to write circle. The area of a circle is pi, and then r times r we can simplify as r squared. And this is our formula that we can use, pi r squared. And pi sometimes will be 3.14. It may be 22/7, another estimation. It may be the exact, or we might be asked to use the pi button. So what is the area again? The area is, the area of a circle is pi times r squared. So pause and take a second to read this problem. Okay, so hopefully you read it. It was about a sprinkler that is a circular pattern, distance of 12 feet, sprays over a distance of 12 feet. What is the area? Draw a diagram. So here is my sprinkler right here, and it sprays in a circular pattern, and it sprays over, so at least 12 feet. So here's my 12, and it rotates all the way around. So the first thing it says is, what does the 12 represent? Well, hopefully you know by now that the center to the side is the radius. So the radius is 12. And then what information is needed? Well, to find the area, we need to know the radius, which is 12 feet. So we are going to do pi times the radius, which is 12, squared. If we wanted to have an exact answer, we would do 12 squared. 12 times 12 is 144, and we would leave it as 144 pi feet squared. So this is the exact. So this is the exact area. I hope you can read that, exact. But if we wanted an approximation, so it made more sense to our heads, we might use 144 times the pi button, or times 3.14. I'll use 3.14. And I came up with 452.16 feet squared. So again, I want you to include the formula, filling in the numbers, and then simplifying with the label. All right, here's another word problem. It is very similar to the last. I want you to read the problem, so pause the video, read the problem, draw the diagram, and then make sure that you read carefully and express your answer to the nearest square foot, and then come back. All right, you need to first add to your notes if you don't have it like me, but second, I am still afraid that some of you are just copying, so I hope that you paused and really did this. So we have our formula. I filled in, she was cutting at 3 feet, and I'm hoping that you are actually highlighting, even though I didn't. So the radius is 3 feet. You're to the nearest square foot, which you'll talk about in just a second, and that you want to find the area. So far, what I have done is I have my formula, I filled out, and I have this. But we have to read the question carefully. We can't just pick out our numbers because this gives me the area of the circle. but it says she's making a circular table out of a square piece of wood. So we have to actually enclose our circle in a square. And it says, how much waste will she have for the project? So we still needed to figure out the area of the table, but we are really looking for this waste right here. And this is very similar to something you're going to have to do on your assessment, so I hope you're paying attention. So we know that this is the area of the circle. To be able to do this problem, we also have to know the area of the square. So if the radius, so half of this, is 3, what would the side length of a square be? The side length of a square would be 6. So the area of the circle is this. The area of the square, is we have to take either length times width, or I hope you know that it is the side length times the side length, or s squared. So now I'm going to plug in one of the side lengths is 6. 6 squared is 36. So to figure out the waste, we are going to have to take the area of the square minus the area of the circle, and that equals 7.74. It says to round to the nearest square foot. Since it's a 4, we're just going to leave it 7.7. And then we're in feet, but because it's the area of the waste, it is going to be feet squared. To recap, what we needed to do was find the area of the circle and subtract it from the area of the square to find our little corner pieces that were waste. All right, last problem. Joan determined that the area of the circle below was 100 pi squared. So because the pi is in there, we know that this is an exact measurement for, if this is true, this is exact because that pi was left in there. She didn't multiply it by the pi button or 22/7 or 3.14. Melinda says that she is incorrect and she believes the area is 100 pi centimeters squared. Who is correct and why? So one of the most important things you can do to show proficiency is being able to find mistakes. So I would start with, I would start with finding the area. So write down the formula, figure that out, and then tell who is correct and why. So what mistake was made? And then see if you can figure out the circumference, because it's important you know the difference between the area formula and the circumference formula. Okay, so how'd you do? So I wrote my formula down, and again, this is important for a few reasons, but the reason it's important now is I can see I need the radius, not the diameter. So I was given the diameter, so I needed to split it in 2 to get that radius, and then I multiplied. They left it in exact, so in terms of pi, so I did 2, and I came up with 100 pi centimeters squared. So I knew that Joan was wrong. And then I had to look at the problem. Okay, what would a common mistake be? Well, we had to split this in 2. 20 times 20 is 400 pi. So I knew that Joan forgot to use the radius. She used the diameter instead. So that was her mistake. So Melinda was correct. Joan was wrong. Then what is the circumference? So then I had to remember, go back to past notes. The circumference is pi times the diameter. So I plugged in my diameter, and because this problem left it in terms of pi, I did for this problem as well. So it is 20 pi. Now another point I'd like to make is notice that the area, because we're doing 10 centimeters by 10 centimeters, it's going to be centimeters squared. But here it was just, it's linear, it's around, so it's just centimeters. All right, that is it. Please start your assignment. Don't forget about 10 marks in IXL and all that good stuff, and we out.